The seasons are just as important in our day-to-day lives as day and night. The 4 seasons, winter, spring, summer, and autumn, help us determine the kinds of clothes we wear, the activities we participate in, and the food we eat. But what causes the change in seasons? The change in seasons is caused by the Earth's tilt and revolution around the sun. Here is another model of Earth and the sun. As the Earth rotates on its axis, it revolves around the sun. If we run an imaginary line straight through the Earth from the North Pole to the South Pole to represent the axis, you can see that our planet is tilted. The Earth revolves around the sun once every 365 days. As it revolves, sometimes the southern hemisphere is tilted toward the sun, and sometimes the northern hemisphere is tilted toward the sun. Try this demonstration at home with a flashlight, paper towel tube, and a beach ball. Turn on the flashlight and hold it a couple feet from the ball and shine it through the paper towel tube. Point the light directly at the center of the ball. Notice that the light beam makes a concentrated circle of light on the side of the ball. This is how sun rays hit the portions of the Earth that are tilted toward the sun. Then, without changing the angle of the flashlight, move it up so the light shines closer to the top of the ball. What happens? Instead of a concentrated circle, the light spreads out and covers a greater area. This is what happens to the portion of the Earth that is tilted away from the sun. The sun's energy is spread out over a greater area and is less intense, which causes cooler weather. Here is another way to demonstrate this principle. When we shine the flashlight on the graph paper from directly overhead, how many squares are illuminated? Now, notice what happens when we hold the paper the same distance from the flashlight, but we change the angle of the graph paper. How many squares are now illuminated? That's right. You can see that light is now hitting more of the squares. Although the light and heat energy from the flashlight are still the same, they are now distributed over a greater area. Each square will experience less of the heat and energy than it does when it is concentrated directly overhead. More squares are sharing the heat and energy, so each one gets a less intense amount. When we have less intense heat to our region of the globe, we experience winter. The sun's rays more directly hit the portion of the Earth that is tilted toward it than the portion that is tilted away. For example, the green band in the northern hemisphere and the blue band in the southern hemisphere are both the same distance from the equator. However, the sun's rays hit the blue band directly because of the tilt of the Earth. We call this direct light. The sun appears higher in the sky, temperatures are warmer, and the days are longer. The blue region is experiencing summer. Meanwhile, in the green region, the sun's rays are more spread out and hit the area indirectly. We call this indirect light. The sun appears closer to the horizon, days are shorter, and temperatures are cooler. The green region is having winter. What happens in our model when the Earth continues its revolution around the sun? In about 6 months, the Earth will revolve to the opposite side of the sun, but its tilt does not change. That means that now the northern hemisphere begins to receive more direct rays from the sun. The days get longer, temperatures get warmer, and summer begins. The southern hemisphere receives indirect rays and falls into winter. The tilt of the planet produces a wide range of temperatures across the planet. The regions along the equator receive the most direct rays from the sun and consistently have warmer temperatures than other parts of the globe. In contrast, the North and South poles get the least amount of energy from the sun and tend to have cooler temperatures than the rest of the planet.